Hello, you guys. Let's talk about rational numbers today. So, look at the first vocabulary word. A quick and easy way to know that a number is rational is, and I want you to use your red, underline the first 5 letters, R-A-T-I-O. That just means you can write it in a ratio. So, any number that can be written as a ratio or a fraction, one number over another number. If you can write it as a fraction, it is rational. Now, if it's in decimal form, there's 2 types of decimals that are rational. First of all, the terminating decimal. Well, think like the Terminator, how he would stop things. Well, terminate means to stop. So a terminating decimal means that it stops. It will not keep going and going. So an example of a terminating decimal would be 0.831. It stops. It doesn't keep going and going. Now, a repeating decimal means it must repeat in a pattern. So, for example, if I had 0.342 with a bar over the 4 and the 2 only, this is what it would look like if I wrote it out. It would be 0.3424242 dot dot dot. Okay? So, and we'll talk more about the bar notation. Okay, look at example 1 with me, identifying rational numbers. Show that the number is rational by writing it as a quotient of 2 integers. So look at A. They want us to write the integer 3 as, well, we can make any integer look like a fraction by putting it over 1. So 3 over 1, we wrote it as a fraction. That means it's rational. Take a look at B, negative 12. We could also write negative 12 as a fraction. Negative 12 over 1. Or you could write it as positive 12 over negative 1. These fractions are equivalent. And remember, anytime you write a number as a fraction, it is, by definition, rational. Okay, take a look at C. They want us to write the mixed number and prove that it's rational. So first thing, we write it as an improper fraction. Remember, start at the 3. 3 times 4 is 12. 12 plus 2 is 14 over 3. And so as soon as we wrote it as a fraction, 14 over 3, then that meant it was rational. Take a look at D. Now when you change a negative mixed number into an improper fraction, I want to show you over here in the margin. I tell people to just circle the negative for a second. We're going to ignore the negative for just one tiny second. 4 times 2 is 8, plus 1 is 9. So I put 9 over 4, and then I bring that negative back. So it becomes negative 9 over 4. And they kind of explain it here, how they did that. But negative 9 over 4, as soon as you see it as a ratio of 2 numbers, a fraction, then it's rational. Okay, let's take a look at example 2, writing fractions as decimals. Now, the trick that you're going to hear me say a lot has to do with a yummy, yummy fast food place called In-N-Out Burgers. Okay, so take a look at this. If I want to write 5 over 16 as a decimal, I'll show you over here in the margin. Write 5 over 16, and then next to the 5, write the word in. Next to the fraction bar, put and next to the 16, out. In and out. So that means I put the 5 on the inside and the 16 on the outside. And then I put the decimal point after 5 and add a few zeros. And then they did all the work for you right here. But you can see that 5 over 16 equals 0.3125. And since it stops at 5, it's what we call a terminating decimal. It stopped. Take a look at B. If I want to change 4/9 into a decimal, well, I still do in and out. So 4 goes on the inside, 9 goes on the outside. I put 4 on the inside, 9 on the outside. I put my decimal point and I add some zeros. Now they did the work for you here, but you can see it's a repeating decimal. Oh, here comes my puppy Fiona to play. Okay, and so take a look here. 4 over 9 equals 0.4 with a bar over it because the 4 would just keep continuing. And you must use the bar notation correctly. So if one number repeats, I only want to see one number with a bar over it. Okay? All right, so we're at the checkpoint. Write the fraction or mixed number as a decimal, and you can always use the in and out trick. So look at number 1. 7 goes on the inside, 20 goes on the outside. So I put 7 on the inside, put my decimal, and I added 3 zeros. And I put 20 on the outside. Well, 20 will not go into 7, but 20 goes into 70 3 times. That gave me 60. I subtracted and got a 10, and I brought down the 0. And now 20 goes into 100 5 times. 5 times 20 is 100. There were no remainders. So this means it stops. It's a terminating decimal. So 7 over 20 equals 0.35, and I box my answer. Take a look at number 2. Now notice that negative in front. I'm not going to ignore it. I'm going to remember it. I'm going to put a 3 on the inside and a 5 on the outside. I put my decimal point after 3 and I added a few zeros. Now 5 will not go into 3, but 5 goes into 30 6 times. And so 6 times 5 is 30. There are no remainders. This means this is a terminating decimal. So watch when I wrote my answer. Negative 3 over 5 equals negative 0.6, and I boxed my answer. Okay, take a look at number 3. We have 2 and the fraction 12/25. So the first thing I did was make it improper. So 25 times 2 is 50, and 50 plus 12 gave me 62 over 25. And then I did the in and out. So 62 on the inside and 25 on the outside. I put my decimal point, I added a few zeros. Bring that decimal straight up. And then when you did the dividing and you need to show your work, I got 2.48. Well, it stops. It doesn't keep repeating. So then this is how I want you to write your answer. Grab the original number, 2 and 12/25 equals 2.48, and you can box your answer. Take a look at number 4, 23 over 40. Well, again, I used the in and out trick. So 23 on the inside, 40 on the outside. I put my decimal point and I added a few zeros. Bring that decimal straight up so you know where it goes in your answer, and then show your work. Do the division. I got 0.575. So again, it stops. So this is a terminating decimal. So 23 over 40 equals 0.575. Okay, now they want you to use decimals to compare the fractions, and honestly that's not normally what I do. What I would normally do is just take the fractions, 42 over 48, and I would try to reduce it. Notice how 6 goes into both, so that would be 7 over 8, so I write 7 over 8 over here, and then I would reduce 27 over 30. 3 goes into both, so that gives me 9 over 10, so I wrote 9 over 10 here. And then remember, I would do the shoot to the moon or shoot to the stars, but I would start at the 8 and shoot across. 8 times 9 gave me 72, and then I would start at the 10 and shoot across. 10 times 7 gave me 70, and then I would just compare the 70 and the 72. Obviously 70 is smaller, so that means 7/8 is smaller. So if I go back to the original form, 42 over 48 is less than 27 over 30. Okay, so now they want us to write terminating decimals as fractions. So notice how they gave us 0.03. Well, you could read it as 3/100ths, so you would know the denominator is 100, and that always works. But if you get nervous, you're at a test, you don't remember your place values, watch this. Use your red, draw a fraction bar, and then underneath the decimal point put a 1, and underneath any numbers after the decimal point put zeros. So there's 2 numbers after the decimal, so I put 2 zeros. So that way you can see it. You can see that it's 3 over 100, and we can't reduce, so box your answer. Okay, take a look at B, negative 9.4. Well, yes, you should know that 4 is in the tens place, so the denominator is a 10. You can also use a trick with your red pen. Draw the fraction bar. Underneath the decimal put a 1, and underneath the number after the decimal put a 0. So you would see that this is negative 9. That negative 9 is a whole complete integer. That's the front of the fraction, the big, write it really, really big, okay, negative 9, but the fraction is 4 over 10. And then I would reduce the 4/10, divide them both by 2, so you get negative 9, and then the fraction 2 over 5. Okay, so this is a really fun trick. Look at example 5, writing a repeating decimal as a fraction. Now, please put this in the margin. When you see a bar, the Repetim bar, think 9s. That's the trick. So look at 0.5 with the bar over it. Do you see how there's only one number repeating? So I only put 1 9 in the denominator, and I just put the 5 over the 9. And yes, indeed, 5 over 9 is the same as 0.5 repeating. Take a look at this next example, 0.23. We'll see how there are two numbers under the bar, and so I put two nines, 99. So this would be 23 over 99. Take a look at the last example, 0.412 with a bar over all three of them. Well, since three numbers are repeating, I'm going to put 999 in the denominator, and this would be 412 over 999. So you can always use this trick as long as all the digits under the bar are repeating, okay? So I want to make this really clear. See this 0.24 with a bar over the 4 only? Because the 2 is not repeating and it's after the decimal, you cannot use this shortcut trick, all right? So you can only use this trick if all numbers are repeating after the decimal. So take a look at this, 0.81 with a bar over the 8 and the 1. All the numbers are repeating. I see two numbers repeating, so I put 99 on the bottom. I put the 81 on top. And this time I can reduce, so 9 goes into both. So 81 divided by 9 gives me 9, and 99 divided by 9 gives me 11. So 0.81 with a bar over the 8 and the 1 reduces to 9 over 11. Okay, so now they're going to ask us to write the decimal as a fraction or a mixed number. Take a look at number 5, 0.8. Well, since it's a terminating decimal, I use my red and I put a fraction bar under the number, and then under the decimal point I put a tiny 1, and under the 8 I put a 0. So I can see that it's 8 over 10, and then I just reduced it and got 4 over 5. Take a look at number 6, negative 3.75. Well, the negative 3 is in front of the decimal, so I write a big negative 3 over here. And then underneath the decimal, I do my fraction bar. Straight under the decimal, I put a 1. Under the 7, I put a 0. Under the 5, I put a 0. So I can see that it's negative 3 and 75 over 100. And then I divided both by 25, and so I got negative 3 and 3/4. Take a look at number 7. Well, I see the repetition bar, so I think of the nines, that trick. Since two numbers are repeating, I put two nines on the bottom, so it's 12 over 99, and then I reduced and got 4 over 33. Take a look at number 8. 5.3 with a bar over the 3 only. Well, since the 5 is in front of the decimal, I put a giant 5 in front of my answer. And since there's a bar, I think nines. I see one number repeating, so I put 1 9 on the bottom. So 3 over 9 could be reduced to 1/3. So it's 5 and 1/3.